Today we are going to solve this problem 724, find pivot index. So let's understand the problem. In this problem we are given an array of integer. So we have to find an index where the sum of all elements on the left side is equal to the sum of all elements on right side. If we find such an index, we return that index. If there is no such index, we return -1. Okay, and let's understand with example. If we have nums of array 1 7 3 6 5 6 0 1 2 3 4 5. Okay, so see here 6 index 3 is pivot, means pivot pivot means the center point or position around which we divide something. Okay, so here left side 1 plus 7 plus 3 is equal to 11. In right side 5 plus 6 is 11. Okay, both are equal, so the answer is 3. Now let's take another example. If we have nums of array 1 2 3 0 1 2, so index 0, left side has nothing, left is equal to 0, and right side is 2 plus 3 is 5, not equal. So if index 1, now left is 1 and right side is 3, right side is 3, not equal. So index 2, left is 1 plus 2 is 3 and right is 0, right is 0, so not equal. So there is no pivot index, so the answer is -1. Okay, now let's take one more example. 2 1 and -1. Okay. 0 1 2, so left side index 0 and right side there is 1 plus -1. Okay, so it was 0, so they are equal, so the answer is 0. So see, so this example is important because the pivot can also be the first index. Okay, so now how can we solve this problem? So let's take this example only. 1 7 3 6 5 6. Okay, we need to find an index where the sum on the left is equal to the sum on the right. Okay, so let's start with index 0. Sorry, it was pen issue. 1 7 3 6 5 6. Okay, 0 1 2 3 4 5. So let's start with index 0. So there is nothing on the left side. Okay, there is nothing on the left side, so left is equal to 0. So on the right side we have 7 3 6 5 6, so the sum of these numbers are 27. Okay, so left is 0 and right is 27, so it was not equal. Now we move to index 1. Okay, now we move to index 1. So now now the left side is 1. Okay, now the left side is 1 and the right side is 3 6 5 6, so the total is 20 from here to here. Now right is 20 and the left is 1. Okay, so again it was not equal. Now we move to the index 2. Okay, we move here index 2. Okay, in the left side we have 1 plus 7 is 8 and right side we have 6 5 6, that was 17. So now our left is 8 and right is 17. It was not equal, so we move. Now our index is 3. Okay, now we come here at index 3. Left side sum is 1 plus 7 plus 3 7 8 9 10 11. Okay, and right sum is 5 plus 6 is 11. So now they are equal. Okay, so index 3 is our answer. So see, but notice something, at every index we are calculating the left sum and the right sum again. Okay, see, from index 2 1 plus 7, index 3 1 plus 7 plus 3, and index 4 like 1 plus 7 plus 3 plus 6. Okay, we are repeatedly adding the same element. So what can we do? we can use the total sum. Okay, see, for the same array, okay, let's write, we have this array 1 7 3 6 5 6. Let's calculate the total sum. So the total sum is 7 8 2 2 14 80 20 and 20 28. Okay, so the total sum is 28. See, total is 28. Now suppose we are standing at index 0. Okay, we are standing at index 0. We know left is 0 and our current element is 1 and the total is 28. So can we find the right sum without adding all the element? Yes. If we remove the left side and the current element from the total, like here, right is equal to total minus left minus current. Okay, so our right is 28 and the left, like right minus 0, left minus current element 1, so it's become 27. Okay, now right is 27. So that's exactly what we got before. Okay, now we move to index 1. Okay, now we move to index 1. We come here at index 1. So the left sum, now the left sum is 1. Okay, now the left sum is 1 and the current element, our current element is 7. Our current element is 7. So right is equal to 28 minus 1 minus 7. Now right is equal to 20. Okay, again we get the correct right sum. Now move to index 2. Now we come here at index 2. Now our, see here, now left sum is 1 plus 7 is 8 and our current element is 3 and right, how can we get 28 total minus left minus current element, so it was 17. Okay, so now it's correct. Now we move to here at index 3. Now our left sum is 1 plus 7 plus 3, it was 11. Now our current element is 6, so our current element is 6 and the left sum is 11. Now see what we do, total minus 8 minus left what, 11 minus current element 6. Wait, 28 minus 11 minus 6, 28 minus 11 minus 6, so it was 11. Okay, now our it's equal to 11 and our left also 11, right also 11, they are equal, so we found our pivot index, that was 3. Okay, sorry for pronunciation, it was pivot. Okay, so we found our answer, so we found our pivot index. Okay, now let's take one more example. Now let's take 2 1 negative 1. Okay, first we calculate the total, so it was 2. Okay, now so our total is 2, so we start from left, 0 1 2, left is equal to 0 and our current element is 2 and total is 2. Okay, so our current element is 2, so what we do, total minus left minus current, so 2 minus 0 minus 2, so the right is 0. Okay, now left also 0 and right also 0, so they are equal, so the answer is 0. Okay, see, notice something important here, the first index can also be a pivot index. Okay, so the first index also be a pivot index, pivot index. Okay, so there is nothing on its left, so that's why we start from left is 0. Okay, let's take one more example. Now I'll take 1 2 3 0 1 2, so the total is 6. So left is 0, our current element is 1 and total minus left 6 minus 0 minus current element 1, so it was 5. Now right is 5. Okay, right is 5. Okay, so we move here. Now our left is 1 and our current element is 2. What we do? 6 minus 1, total minus what is this? Left 6 minus 1 5 minus current element 2. 5 minus 2, it was 3. Okay, now our right is 3. Now our right is 3 and we move to at index here, at index 2. So 6 minus 3 minus 3, it's 0, so it was not equal. So we check every index but we never found. So when left is equal to right, so here is no pivot index. Okay, so the answer is -1. Now see what did we run from all 3 example? We can see one pattern. We do not need to calculate the right side separately. We already know the total sum. So at every index, what we are doing, right is equal to total minus left minus current element. Okay, so see what we are checking. If left is equal to right, if they are equal, we found our answer. Otherwise we add the current element left and move to the next index. So this is the idea we are going to convert into code. Okay, now see, now we already know our idea. Total is sum of the whole array and left is sum of the element before current index, and right is total minus left minus current element. Okay, now let's write down the code. So we need to create a variable total, int total is 0. Okay, so we need the total sum of the entire array. So we create a variable called total and start it with 0. Okay, now let's understand with example only. So if we have numbers of array 1 7 3 6 5 6, now our total is 0. Okay, now we have to calculate the total sum for in x is to nums total plus equal to x. Okay, so here we go through every element of the array and add it to total. Okay, like this. X is equal to 1 1 7 3, x is equal to 1. Now our total become 1. Okay, if x is equal to 2, x 7, sorry, in x is 7, now our total become 8. When x become 3, our total become 11. When x become 6, when x becomes 6, our total becomes 17. When it's become 5, our total become 22. When it's become 6, it become 28. Okay, now our total is 28. Okay, now we know the sum of the entire array. Then we create left sum. Then we have to create left sum, and left is equal to 0. So we need another variable to store the sum of elements on the left side. So we called it left, which means left. Okay, we called it L, which means left. Okay, why do we start with 0? Because when we are at the first index, like see here, there is nothing left. Okay, so left is equal to 0. That's why we start with 0. Okay, now we have checked every index. For int I is equal to 0, I is less than dot size, and then I plus. Okay, now we need to check every index because any index can be our pivot index. Okay, sorry for pronunciation of pivot. So here I see here 0 1 2 3 4 5. Now here I is equal to 0, then I is equal to 7 3 and so on. Okay, then we have to calculate the right sum also. Let's write int right is equal to TOTAL total minus left minus nums of I means our current element. Okay, current element. So here it means now our left sum is 11 and our current element is 6, nums of I is 6, current element is 6, and our total is 28. Okay, total is 28. Okay, so left press, current press, right. So now we write this. So it means 28 minus 11 minus 6. Okay, now we check. Now we have to check if left is equal to right. Return I. Okay, so for this example, left also become 11 and right also become 11, so that we return this index. Okay, index 3. So we update left. So see, we have to update the left sum. What happen if left is not equal to right? When the current index is not our pivot, so we move to the next index. Before moving, the current element should become part of the left side. So that's why we write equal to nums of I. Okay, then we write. So see here, why do we update left after checking this? Because the current element belong to the neither the left side nor the right side. Okay, so see here, so left is 1 plus 7 plus 3 and right is 5 plus 6. So the 6 at the pivot is not included in either sum. Okay, this one. So we first calculate this. Right is equal to total minus left minus current element. Then we check if left is equal to right. So only after that, if we move forward, the current element become the part of the left side. Okay, so that's why we write left place equal to nums of I. Okay, that's why the order is important. Okay, though no, see, what if there is no pivot? Okay, after checking every index, what if we never find left is equal to right? Then there is no pivot index, so we just return -1. Okay, in last we just return -1. Now let's correct the code. See, this line means stole the sum of the entire array. Then we calculate the total sum. So initially there is nothing on the left. Then we check every index as possible pivot index. So right sum is equal to total sum minus left sum minus current element. Okay, then if left sum and right sum are equal, we found the pivot index. So this means move the current element to the left side, and if no pivot index was found. Okay, so the time complexity of this, see, for time complexity we traverse the array 2 times. The first traverser is calculate the total sum, and the second traverser find the pivot index. So the overall time complexity become big O of n, and for space complexity we only use a few variables and no extra data structure. Therefore the space complexity become big O of 1. That's all.